Hello, pre-calculus students. Today, uh, we're going to be going over the practice test for Unit 1. So I have the practice test on my left, Microsoft Paint on my right. So I'm going to draw the solutions on Microsoft Paint and write the answers on the practice test. Okay, so let's start with 1, f of x. It's going to be equal to x squared plus 2x minus 3. That's fair. And we need to find f of x plus 3 minus f of 3. All right, so what we need to do is plug in x plus 3 into the equation, plug in 3 into the equation. So for f of x plus 3, that is going to become x plus 3 squared plus 2 times x plus 3 minus 3. So x plus 3 squared, so make a special note about this. X plus 3 squared is x plus 3 times x plus 3, which becomes x squared plus 3x plus 3x plus 9, and 3x plus 3 so becomes x squared plus 6x plus 9. So x plus 3 becomes x squared plus 6x plus 9, 2 plus 2x plus 6 minus 3. So we combine like terms, which is 1 x squared term, and 6x and 2x. Six x term here and a 2x term here, so we have x squared, 6x plus 2x is 8x, so x squared plus 8x. And then that's the plus 9 and the plus 6, so 9 plus 6 is 15, minus 3 is 12, so 9 plus 6 is 15, minus 3 is plus 12, okay. So that's for our x plus 3 term. That's f of x plus 3. Minus f of 3. So what is f of 3? F of 3 is just going to be plugging 3 in, so that's going to be 3 squared plus 2 times 3 minus 3. So 3 squared is 9. 9 plus 6 minus 3. So it's going to be minus 12. And when you have x squared plus 8x plus 12 minus 12, these 12s are going to cancel out. Plus 12 and positive 12 and negative 12 cancel out. Their final answer is going to be x squared plus 8x. So that will be the final answer. All right, so this should be the work on a separate sheet of paper. And you can always rewind if you need further explanation. Okay. All right. Let's go to number 2, tell whether each represent y as a function of x. So for a, we just say, is y a function of x? So y is equal to 1 over x squared. This is a function. So for that a, it's going to be yes. This is a standard rational function. It's a rational function. All right. For b, if y plus 5x squared is equal to 2, you can rewrite that as y is equal to negative 5x squared plus 2, which is a polynomial function. So that's going to be a yes, that's going to be function c. Y is equal to x minus 3 squared plus 2 is a quadratic function. For d, 2y squared plus x equals 22. So I'll have to subtract x from each side. 2y squared is equal to negative x plus 22 divided side by 2. Y squared is equal to negative 1/2 x plus 11, and then lastly, y is equal to the square root of negative 1/2 x plus 11, which is a radical function. So we have for A, B, C, and D, yes, 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 yes. Now let's look at E. For E, we have the absolute value of y minus 1 is equal to 2x. And so this actually creates two statements that we could have. One is that the absolute value means the distance of 0. So this absolute value means two things could be true. One, y minus 1 equals 2x. And two, that's going to be negative y plus 1 equals 2x. So we have y minus 1 equals 2x. You just add 1 to each side. And you'll have y is equal to 2x plus 1. But for this one, you could subtract 1 from each side. And you have negative y is equal to 2x minus 1. But then you multiply each side by negative 1 to isolate y. Multiply by negative 1, multiply by negative 1. So you'll get y is equal to negative 2x plus 1. So y is equal to 2x plus 1, and y is equal to negative 2x plus 1. What's that going to look like on a graph? On a graph, you're going to have 2x plus 1 and negative 2x plus 1. So you'll have a line with a positive slope and a line with a negative slope. And it's not going to be y as a function of x because that fails the vertical line test. So this is going to be no. The last one, we will have 9x minus 2y equals negative 3. Isolate the y, subtract 9x from each side. Negative 2y equals negative 9x minus 3. Divide each side by negative 2. And you'll have y is equal to 9 halves x plus 3 halves. And that is a linear function. So this is going to be a yes. All right, so which of the following are one-to-one functions? So remember, one-to-one functions, as a reminder, with one-to-one functions, each input has one and only one corresponding output. Sorry. So that's corresponding output. So furthermore, passes the horizontal line test, and the inverse is a function. Be very clear, not the inverse is an f of x, the inverse is a function. All right. All right, so now we have to look at which is a one-to-one function. Let's look at A. A is a circle with a radius of 4. Center is 0, 0, and the radius is equal to 4. So therefore, remember A is, so with x squared plus y squared equals 16, we would have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Just have a circle which fails the horizontal line test. Fails the horizontal line test. Not one-to-one. Okay, so that's A. That's not one-to-one. For B, the square root of square root of 7 minus x, and y is equal to the square root of 7 minus x. we can say, is that 1-to-1? Well, looking at the function, it'll probably look something like, we'll have a shift. It'll be shift right 7. It'll be the square root function like that. So that square root function will pass the horizontal line test. So the root function passes the horizontal line test. Okay. Let's take that image. So b is a function 1-to-1. For c, y is equal to 3 to the x minus 4. And so this is just an exponential function shifted right before. So essentially the function more or less is going to look something like this, where you have shift right for a function that's going to look like that. That's 1-to-1, passes the horizontal line test. So that's going to be 1-to-1. And the last one is the absolute value of y equals x. When the absolute value of y equals x. That gives us two statements. One is y equals x, and the other is negative y equals x, which means that y is equal to negative x. So when we graph that, it's going to have two lines, both at the origin. The one is a linear function with a positive slope, one is a linear function with a negative slope. And that is going to cause a problem right there. One, it fails the vertical line test, but two, it also fails the horizontal line test. So it's not 1-to-1, okay? For number 4. We have f of x is equal to negative, f of x is equal to negative 2x minus 2 when x is less than or equal to negative 1, and then f of x is equal to the square root of x minus 2 when x is less than negative 1 when you graph the function to the right. So when we graph this function, what we'll do here is we're gonna notice something, is that the first function is when x is to the left of negative 1, and the second function is when f is to the right of negative 1. So if x at negative 1 to negative 1, that's the point where we stop. And then we have the original function 2x minus 2. So originally we have the y-intercept at -2, and then the slope is why is that going away? Right, up 2 over 1. Up 2 over 1 gets the slope -2. Up 2 over 1. Up 2 over 1. Up 2 over 1 and up 2 over 1. We will only have points, remember, when x is less than or equal to -1. So take note that at -1 I have that filled in circle. So up 2 over 1. So you'll have a line going right there. Now, the second function is the absolute value of x minus 2. So we will have our absolute value function shifted right 2. So that's right 2. So here we go right 1, 2, and we have an absolute value function with a linear slope. So we'll have a point there, and then at this point we'll have a point here, and then remember, because it's greater than -1, but not greater than or equal to -1, so at -1 we have that hollow hole like that, and keep on graphing the absolute value parent function. Alright, so we graph the function as such. Essentially, you just have to be able to graph functions and restrict the domain. So we defined f of -2. So f of -2 is going to apply to the first function. So f of -2 is less than -1. That's going to be -2 times -2 minus 2, which is equal to 4 minus 2, which is equal to 2. So f of -2 is 2. F of -1, well, -1 is going to be equal to -1, so that's going to go with the first function. That will be -2 times -1 minus 2, which is equal to 2 minus 2, which is equal to 0. So I'll have 0 for the second function. And then for c, f of 6 is greater than -1, so 6 is going here. So f of 6 will be equal to the absolute value of 6 minus 2, which is equal to the absolute value of 4. That's going to be equal to either 4 or -4. So that will be 4 or -4. Say the domain and range of function number 4. State any points of discontinuity. So the domain, this is one where you can just the domain is from -infinity to infinity. No rational functions. That's because with these functions right here, you have no rationals, no roots, no logs. For the range is the set of all y values. So the lowest y value here is 0, but there's no y values below 0. So the range is going to be from 0 inclusive to infinity, and the discontinuity is going to be at x equals -1. And that's just because if you zoom in here, the functions are not continuous at x equals -1. Look where my cursor is. When the two useless functions meet, they're not continuous. Alright, so keep on going. For problems 6 to 9, give the domain range of each function using interval notation. So for 6, we have f of x is equal to 1 over square root of x squared plus 1. So we're going to have two statements. One is that we cannot take the square root of a negative number, and two is that we cannot divide by 0. So the first statement is saying, let's say we can't take the square root of negative. So let's solve for that. If we can't take the root of the negative, then when we have the square root of x plus 1, we look at that x squared plus 1 and say that can't be negative. So if x squared plus 1 can't be negative, it must be greater than or equal to 0. Do some algebra here. Subtract 1 from each side. X squared must be greater than or equal to -1, square root of each side. So the square root of x squared is x, and if you remember from Math 3, the square root of -1 is I, which is an imaginary number. So that's an imaginary number. Imaginary number, which is equal to the square root of -1, because the square root of -1 doesn't make sense. Okay, so that's one domain statement that we have. X is greater than or equal to I. Okay. Then for 2, you can't divide by 0. So in order to not divide by 0, we have to take the whole term in the denominator and say that that cannot equal 0. So you'll have square root of x squared plus 1 cannot equal 0. Square both sides. So the square root of, I'm sorry. X squared plus 1, 0 squared 0, cannot equal 0. Subtract 1. X squared cannot equal -1. Take the square root of each side. X cannot equal -1. So that's our restrictive domain statement. And so because the domain must be the most restrictive domain, so you must have most restrictive, that's one word by the way, domain. So therefore, this one says x must be greater than or equal to I. This one says x cannot equal to I. So the actual domain between the most restrictive of the two becomes x has to be just greater than I. But the domain's actually going to be all real numbers because I is an imaginary number. An imaginary number is not a real number. So the domain is going to be all real numbers. So the domain is going to be from negative infinity to infinity because imaginary numbers aren't real numbers. Okay? So imaginary numbers, remember, they're not real numbers. Okay. All right, let's go to number 7. With number 7, we will have f of x is equal to the square root of 3 minus x and the square over the square root of x minus 2. Here, x minus 2 has to be greater than or equal to 0. So x must be greater than or equal to 2. So that's one statement. Another thing we have to value for is that 3 minus x must be greater than or equal to 0. So that means negative x must be greater than or equal to negative 3, which means that x must be less than or equal to. So 3. So one thing to do is if I multiply by negative 1, I flip the sign. That's another statement we must abide by. And then lastly, we have the square root of x minus 2 can't be equal to 0. So we have the square root of x minus 2 cannot equal 0. Square each side. X minus 2 cannot equal 0, so x cannot equal 2. And from this, we have to choose our most restrictive domain, which is going to be that's the domain here. We choose the most restrictive domain for the function, and so here x cannot be 2 equal to 2. That's going to interfere with this where it says x must be greater than or equal to 2. So the domain ultimately becomes x must be, so x has to be greater than 2, but less than or equal to 3. So in interval notation, we can express that domain as from 2 inclusive to, 2 not inclusive to 3 inclusive. All right, so that's the domain. I'm going to go back and do the ranges. Let's go to 8. For 8, we have 1 over x cubed minus 3x plus 2. Oh, sorry, that says x squared, sorry. 1 over x squared over 3x plus 2. So the first thing I'm going to do is factor. So that's 1 over 2 factors here. X times x is x squared. And to multiply the 2, I can choose either 1 and 1 or negative 1, negative 1. Sorry, multiply by to 2, I'm going to choose either 2 and 1, positive 2 and positive 1, or negative 2 and negative 1, and choose negative 2 and negative 1. X times x is x squared, x times negative 1 is negative x, negative 2 times x is negative 2x, negative 2x plus negative 1x is negative 3x, negative 2 times negative 1 is positive 2. All right, that works. So we have x minus 2 and x minus 1. So for the domain, you just can't have the denominator equal to 0. So for the domain, x minus 2 cannot equal 0. X minus 1 cannot equal 0. So that means the domain is x cannot equal 2. That's one statement. And x cannot equal 1. These are our two statements. How do we express these statements in interval notation? So that's all numbers except for 2 and 1. So for 8, the domain is from negative infinity to 1, not inclusive, union from 1, not inclusive to 2, union, then from 2 to infinity. So that's more challenging in interval notation. In set notation, you can just write x such that x is not equal to 2 and not equal to 1. That's set notation. Okay, let's go to 9, and we'll circle back for the ranges. For 9, e to the x plus 2 minus 5. F of x is equal to e to the x plus 2 minus 5. So, how do we go about that? Well, the domain, this is an exponential function. Right? You're not dividing by 0. You're not dividing by 0. You're not taking the square root of a negative number. You're not taking the logarithm of 0 or a negative number. So the domain is just going to be all real numbers. Domain, all real numbers. Okay, now we're going to circle back to the ranges. For the range of the functions, the best way to look at it is you can get in a sense by graphing them. So the first function is 1 divided by the square root of divided by the square root of x squared of x squared plus 1 all right, and let's graph that. So we can look at that table right there. Second table. It looks like the highest value is going to be 1. It's just going to get smaller and smaller and smaller and smaller and smaller in either direction. But the highest value will be 1, and that's when x equals 0. And the reason why is because if you just think about it, the function is going to get smaller and smaller, or get closer and closer to 0 as x gets larger. So the range here is going to be from 0 not inclusive to 1 inclusive. And I got that intuitively from the calculator just looking at it. And to get this part, you're going to have to listen to my explanation. Okay? So if x is 0, the denominator is the smallest it will ever be. But as soon as x increases, you get a larger and a larger denominator. And with a larger and larger denominator, you are dividing by a larger and larger number. And when you divide by a really large number, you approach 0, but you never touch it. Okay? If I have a millionth of 1, that's really close to 0, but it isn't 0 yet. Okay? So what about 7? You have a range of 2 to 3, right? We have a domain of 2 to 3. So I'm going to calculate 7, the range of 7 by hand. I can find this range by plugging in 2 and plugging in 3. So therefore, this just becomes the square root of 3 minus 2 over the square root of right. So if this is because it can't actually equal 2, this would be like 2.1 approximately minus 2, which is going to be the square root of 1 over 0.1. Would actually be an infinitely small number, so this would ultimately become like the square root of 1, which is 1, by the way, over 0.000000001. So it's going to be approaching 0, but not actually 0. So that approaches 0. So we would have a range of 0 not inclusive to when x equals 3. We would have 3 minus 3 all the way over 3 minus 2, which is going to be 0 to 1. So you have 0 on the left-hand side as well. But it seems like the highest number, yeah, so it looks like you just have a range of 0. I might use my calculator to further verify the range. If I have function is the square root of 3 minus x divided by the square root of x minus 2. Let me go to the table, right? Oh, does most of this. It's not being super helpful. So we have square root of 3 minus x over the square root of x minus 2. Okay, yes. So we have, oh, right, at oh, right, okay, so when x approaches 2, oh, because you're dividing by 0.001, that actually approach you from infinity. So the range is going to be from here, the range is going to be from 0 to infinity. And that's because as x approaches 2, it doesn't touch 2. You'd be dividing by 0.0001, which makes you dividing by a fraction. It's like multiplying by that large number, the denominator. So that makes you approach infinity. All right, and for number 8, the range. But in the interest of time, I'm just going to one over x squared. Have 1 over x squared plus minus 3x plus 2. This is mostly so we can explain this better. But that range is going to be from 0 to this should be 0 to infinity. Yeah, because you have that, we have those asymptotes. Because you have those asymptotes, you have vertical asymptotes. You have vertical asymptotes and horizontal asymptotes. Because you have those vertical and horizontal asymptotes, your range is from negative infinity to infinity. Except for you do have a break right here between 0 and negative 4. So it actually ranges from negative infinity to negative 4, and from 0 to infinity. So the range here is from negative infinity to negative 4, and then from x squared minus 3x plus 2. Yep. And then from 0 to infinity. You get that union. So there's union there. Fine. The domain is all real numbers. Here, the range is going to be from -5 to infinity. So just Desmos an exponential function, but essentially that's an exponential function shifted down 5. Okay. For 10 and 11, determine whether the function is even, odd, or neither. So let's select that image. So let's determine whether it's even, odd, or neither. So we have 3x squared plus 2x cubed. I'd like to rewrite that as 2x cubed plus 3x squared. When we're even, f of negative x equals f of x. Odd, f of negative x equals negative f of x. So that's for even, this is for odd. So we evaluate f of negative x here. That's going to be equal to 2 times negative x cubed plus 3 times negative x squared, which is equal to negative 2x cubed plus 3x squared, which is not f of x or negative f of x, because that's equal to f of x. And negative f of x is equal to just switching up the numbers. So that means that's a neither. So neither here. All right. For 11, f of x is equal to 2x squared minus the absolute value of x. So f of negative x would be equal to 2 times negative x squared minus the absolute value of negative x. And 2 times negative x squared is just x, so that becomes 2x squared. And absolute value is the distance of 0, so the absolute value of negative x is the same absolute value as x, because negative x and x have the same distance from 0. It's going to be minus x, still equivalent to the absolute value of x. So in this case, you can say that f of negative x is equal to f of x. That is true. So that says f of x is even. All right. What's the intervals for the function f of x equals 3x to the 4th power minus 6x squared is increasing, okay? This is one where we can use our calculator. So it should be 3x to the 4th power minus 6x squared. That So when is it increasing? You can see the function will be increasing. The current one, let's just make that -3.
Here.
Okay. So notice it's increasing from -1 to 0, and it's also increasing from 1 to infinity. So we can say that's increasing from -1 to 0, and then from, oh, sorry, that's 1.5. We can use the trace button. Yeah, actually, this is the right way to do it. Yeah, it's -1. And then, yeah, that'll be about 1 to infinity. Okay. For 13, given f of x equals x plus 1, g of x equals x plus 2, h of x equals x squared minus 1. Find each of the following g of f of x. So that means actually the input is square root of x plus 1 plus 2, which is equal to the square root of x plus 3. And so f of g of 14 g of 14 is going to be equal to g of 14 square root of 14 plus 2. That's g of 14 square root of 14 plus 2, which is equal to the square root of 16. So that square root of 16 is equal to 4. So then you're finding f of 4, which is equal to 4 plus 1, which is equal to 5. F of g of 14 is equal to 5. F over g of x. F over g of x is the same thing as f of x over g of x, which is just equal to the square root of x plus 2 over x plus 1. 2 over x plus 1. And for d, that's f minus h of x. So that's just going to be f of x minus h of x. So for d, that'll just be x plus 1 minus x squared minus 1. So just combine the polynomials. That'll be negative x squared plus x, and the plus 1 minus 1 cancel out. This is negative x squared plus x. Negative x squared plus x. Domain of f of g of x and g of f of x. Well, let's f of g of x is equal to square root of 3x, sorry, square root of x plus 2 plus 1. So the main thing is that just has to be greater than or equal to 0. That just means x plus 2 is greater than or equal to 0. So x is greater than negative 2. So the domain of f of g of x is from negative 2 to infinity. Then the domain of g of f of x, or g of f of x, is the square root of g of f of x. That is equal to square root of x plus 3, so you have x plus 3 must be greater than or equal to 0, x must be greater than or equal to negative 3. So when x is greater than or equal to negative 3, you just have the domain from negative 3 to infinity. Find the inverse of f of x. So in this case, given f of x equals square root of 2x, and find the inverse of the function, giving any restrictions to any scatter graph. So for 14, we have f of x is equal to the square root of 2x minus 1. We need to find the inverse. So first of all, we can start out with x is equal to the square root of 2y minus 1, and square both sides. So x squared is equal to 2y minus 1. You could add 1 to each side. So that means that x squared plus 1 is equal to 2y. Divide each side by 2. And I'll ultimately get y is equal to 1/2 x squared plus 1/2. And just for fun, yeah, 1/2 x squared is 1/2. So, and then given all restrictions, you just, the main restriction for this is just that for originally f of x, we say that for f of x, the restriction is that y is greater than or equal to 0. And we'll do that. And then we need to sketch such a graph. So 1/2 x squared plus 1/2. It's going to be go up 1/2, and you have a shrunken parabola. So the inverse of the function equals 1/2 x squared plus 1/2. Find the inverse. So for 15, f of x is equal to 2x, sorry, 2 plus 3x over x minus 4. So what that means is that x is equal to 2 plus 3x over x plus 2 plus 3y over y minus 4. So what that means is that multiply each side by y minus 4, you'll have xy minus 4x is equal to 2 plus 3y. Okay? So then get all the y's on each side. Xy minus 3y equals 4x plus 2. Y times x minus 3 is equal to 4x plus 2. And just divide each side by x minus 3. This cancels out. That's not a negative, by the way. So the inverse of the function is y is equal to 4x plus 2 over x minus 3. So the inverse of the function is equal to 4x plus 2 over x minus 3, or negative 4x minus 2 over negative x plus 3. Find the horizontal and vertical asymptotes of the function. How you doing? Doing good. Wow. All right. So for 15, we need to find the vertical and horizontal asymptotes of f of x. So using our brushes, we see that f of x is equal to, let me adjust my tablet here, 5x squared over 2x squared minus 11x minus 6. And so what I'll first do is I want to factor the denominator. So when I factor it, f of x is going to be equal to 5x squared will be on the top. And then when you factor this, factors of 2x squared, only possible ones we could start out with would be 2x and x. And now we need two factors values that multiply to negative 6, and then are going to also multiply by 2, and then multiply by 1, and then add to negative 11. So let's look at, let's say, negative 6 plus 1. Negative 6 and positive 1 will multiply to negative 6. And to double check the factor, 2x times x is 2x squared. 2x times negative 6 is negative 12x.
1 times x is x, and 1 times negative 6 is negative minus 6. That becomes 2x squared minus 11x minus 6, okay? So we check that factoring is correct. It is. So for our vertical asymptotes, go to our brushes and know that we can't have any of our terms in the denominator be equal to 0, so we'll have 2x plus 1 equals 0. This is for our vertical asymptotes, which means that 2x has to be equal to negative 1, which means x equals negative 1/2 is a vertical asymptote. And furthermore, x minus 6 equals 0 is another vertical asymptote. So x equals 6, that's your vertical asymptotes. Your vertical asymptotes would be at x equals 6 and x equals negative 1/2. Now when you look at our horizontal asymptote, well, at our horizontal asymptote, we wouldn't have the horizontal asymptotes essentially, because we have the same degree in the numerator and denominator. So our numerator degree equals 2 and the denominator degree equals 2. Then eventually, as x gets really large or really small, you'll have a slant asymptote at 5/2. Slant asymptote at y equals 5/2 x. Okay, and the reason why is that when x gets really large, the x just overpowers and ultimately becomes 5/2. So actually, I might use that. Not use that terminology. I'll bring out Desmos just to show you what I mean. So we'll have 5x squared over 2x squared minus 11x minus 6. So 5x squared over 2x squared minus 11x minus 6. Okay. Yes, you're going to have horizontal asymptotes at vertical asymptotes at the stated point and horizontal asymptotes at 5/2. You're getting closer and closer to 2.4, which is almost 5/2 is 2.5. So you're approaching 2.5 from the left and the right, but you're not doing it. So you have a horizontal asymptote at 2.5. Yeah. So so y equals 5/2. That's your horizontal asymptote. So sorry for using the term slant, but it's horizontal asymptote. And there's no even 5/2. It's just at y equals 5/2. Okay. So our horizontal asymptotes is going to be y equals 5/2, and our vertical asymptotes are going to be at x equals negative 1/2 and x equals 6. Okay? Moving along. For 17, given f of x equals 1 over x squared, oh, 1 over x plus 2, sorry, and g of x is equal to 1 over x minus 2, find the domain of g of f of x. That's going to be equal to, you plug f of x into g of x, so you have, so g of x is 1 over, and then f of x is 1 over x plus 2, so it'll be 1 over x plus 2 minus 2. So to simplify this, I'm going to multiply that 2 by x plus 2 over x plus 2 to get a common denominator. Next step, I'll have 1 over x plus 2 minus 2 times x plus 2 over x plus 2, so that's going to be equal to minus 2x minus 4 over x plus 2, which will be equal to 1 minus 2x minus 4 is going to be equal to 1 over negative 2x, and 1 minus negative 4 is going to be 1 plus 4, which is going to be 5. So 1 over 2x plus 5 over x plus 2. And when you have 1 over fraction, you can flip the fraction. So it's going to give us ultimately a fraction of, this is going to be equal to x plus 2 over negative 2x plus 5. So now we need to find the domain. So for our domain, we can't have a denominator of 0, so negative 2x plus 5 cannot equal 0. Do some algebra, negative 2x cannot equal negative 5. So that means x cannot equal 5/2. So our domain, if x cannot equal 5/2, would be from negative infinity to 5/2 union 5/2 to infinity. The 5/2 is not inclusive because x can't include a value of 5/2. Alright, so that takes some algebra. Let's go to the next problem. For 18, you graph the function on a calculator and say whether the function is continuous at x equals 4. If it is discontinuous, determine if it's removable or not removable. So let's do the first one. Three x squared minus 4x. Alright, we are graphing. Let's change that window in a second. Alright, so let the x max be 4, the x min be negative 1. Alright, y min is negative 3, y max is 2.5. Let's do from negative 3 to 3, so we can graph. Let's increase that window for our y max. Let's do negative 10 and 16. constantly adjust file windows. So at x equals 4, you do have the function continuous. So for a, it is just continuous. All right, and then for b, it's 2 over x squared minus 16. 2 divided by x squared minus 16. Got that. All right, for that window, might want to significantly increase that y max. Let's do that to 1,000, and that y min to negative 1,000. Graph that. Okay. So clearly, looking at the function, it's not continuous at x equals 4. And you know that because you have if x was 4, then you would have a 0 at the denominator. And that's going to be non-removable. Yeah, that's non-removable, and the reason why it's non-removable is because you have a vertical asymptote. So not continuous, non-removable. Not continuous, non-removable. Okay. Next bunch is just a bunch of transformations, okay? So for the transformations here, we're going to have 2 times f of 3 minus x plus 1. So that 2, vertical stretch of 2, all right, so right away we can say vertical stretch by 2, right, comma, and then 3 minus x, we can also rewrite that as f of negative x plus 3. Factor out that negative 1, f of negative 1 times x minus 3 plus 1 plus 1, okay? So that's going to be, the negative 1 is going to be a y-axis flip, y-axis reflection, right 3, and up 1. So that's a vertical stretch by 2, y-axis reflection, right 3, up 1. Okay. Looking at the next problem, we have our function, negative 3 times the square root of 2x plus 4. We just need to factor out what's inside the square root, so we'll have negative 3 times the square root of, factor out that 2, times the quantity of x plus 2. Alright, so that negative sign x-axis reflection. We'll have a vertical stretch by 3, horizontal shrink by 1/2, and then that'll be left 2. So describing this transformation, we'll have an x-axis reflection of vertical stretch by 3, horizontal shrink by 1/2, so that's just 1 over whatever that factor is if it's greater than 1, and left 2. Alright. Write the equation of the graph contained by the following transformations of the parent function. Okay. So in this one, I might not even need to use Microsoft Paint because I just read the function and write down the transformation. So you have a horizontal shift of 2, vertical shift down 4, reflected across the x-axis. So this function is going to be f of x is equal to the absolute value. We have it reflected across the x-axis, so negative of a minus sign outside of the x term, x, left 2, plus 2, close the absolute value brackets, and then down 4. Here, y is equal to the square root of x. So for a new function, we have a y-axis reflection, so we're going to have a minus negative coefficient on the outside. A vertical shrink of 1/2. Vertical does what you think it is, so you have times 1/2. A horizontal shift, right 5. So it'll be square root of x, and x will be in parentheses, right 5, so that's minus 5. And then for 23, we have the graph has a vertical shift up 3, horizontal expansion of 4, horizontal shift right 1, and a vertical stretch of 2. So let's start out with the vertical stretch of 2. So f of x is equal to 2, and then we'll have horizontal expansion of 4 times 1/4 of a horizontal shift right 1, x minus 1, and then I guess the last thing is a vertical shift up 3, plus 3. Okay, so that's our Unit 1 review. That's the entire video.